Okay, so we're just going to do an introduction to logarithms. So there'll be a couple of videos on logarithms because there's a few things we need to talk about, but this is just a basic introduction so that we understand what logarithms are. So to understand logarithms, it helps to look at exponential functions because logarithms and exponential functions are actually inverse functions. So let's start by looking at an exponential function that looks something like this, right? This function says, if I raise a to the power of x, I get a y. So if I raise a to the power of x, I get a y. That's what this guy says. And we're used to working with him a little bit. We've been working with him some. Now, a logarithm, he looks funny and sometimes it makes people nervous. But a logarithm basically says the same thing. This one says, the power that I have to raise a to, so the power that I have to raise a to get y is x. The power I have to raise a to get y is x. That's what this one says. Okay? Now they basically say the same thing. Pretty much the same. The only difference is the output here in this function is actually the exponent. So this one would be the exponent. So this is the power that I have to raise a to get y. And over here, this guy is the exponent, of course. And this one is, we'll call him the value you get after you multiply. So that is the same thing as this one here. So they've switched places, if you notice. The output of this one, I called it x just to make it look like this one. But the output of this one, so the x here, is the exponent, and the output of this one is the value after you multiply. The input of this one is the exponent, and the output of this one is the exponent. So do you see how they've switched places? It was the input here, and now it's the output. The output here is the value after you multiply, and the input here is the value after you multiply. So that's what inverse functions are about, right? The domain and the range, they switch places. So let's take a look at a couple of these so that we can understand what we're talking about. So if we're looking at this one, and I'll write it this way because this is the way we usually see things, set equal to y. The way that we read this says log base a of x is y, or is equal to y. So log base a of x is y. And we know that this guy is always representing, he's always representing an exponent. So this is asking me that same question that the other one is asking me. It says, what do I raise a to get x in this case? This guy being my base. And we even say that word when we read this one aloud. We call it log base a of x is equal to y. And this one will be the value after we multiply. Now we could rewrite these as exponents in exponential form, or we can write them in logarithmic form. If I rewrite this one, right, we just saw what that would look like. It says base a to the what is equal to x. So this would be in logarithmic form, and this one would be in exponential form. And you can write the same thing in either form. You can give the same information in either form. Now, why do we even bother with logs? It's so that we can solve equations that we can't solve before, because when we have something, the variable as the exponent, we're not usually able to solve for that. But if we use logarithms, we'll be able to do that. Now, we're not going to solve any in this video. We're just going to look at a few and evaluate them to try to wrap our brain around this idea. So if I take something like this, it says log base 3 of 27. This is actually saying the value of the exponent. So I'm the value of the exponent that you raise 3 to get 27. So this is asking me basically this question. 3 to the what is equal to 27? Whatever this question mark is, that's what this guy is equal to. He's equal to that exponent. And so from here we can see that the number that I have to raise 3 to get 27 is 3. All right? The number that I have to raise 3 to get 27 is 3. Let's look at another one. Log base 4 of 1 over 16. So this one, what I should be saying is, what number do I have to raise 4 to get a 16? So in other words, if you're having a hard time understanding it, it's log base 4 of what? Or 4 raised to the what is equal to 1 over 16. Now we looked at solving something like this, right? If we make them both the same base, we could say 4 to the what is equal to, this is 1 over 4 squared. So 4 to the what is equal to 4 to the negative 2. Well, obviously, what's this little question mark here equal to? It's equal to negative 2. So this whole little expression is saying I'm the number that you have to raise 4 to get 1 over 16. In other words, I'm negative 2. Okay? Let's look at a few more just to get our brain revved up for logarithms. Let's try a few of these. So we'll say evaluate. So in other words, when you evaluate an expression, you're giving the value of that expression. All right? So here's my first expression. Log base 5 of 25. Log base 5 of 25. Well, what should my brain be saying right now? It should be saying, what do I have to raise 5 to get 25? And what do I have to raise 5 to get 25? It's a 2. In other words, 5 squared is equal to 25. I'm looking for the exponent. How about this one? Log base 5 of 1 over 125. Well, again, what should my brain be asking me? What do I have to raise 5 to get a 1 over 125? Well, hopefully you see that this is 5 to the third, and it's on the bottom of the fraction. So this guy is equal to a negative 3. It's equal to that exponent. All right, let's just do a couple more. Log base 5 of 5 squared. So this is, what do I have to raise 5 to get 5 squared? Hopefully everybody is screaming right now that it's a 2, right? So what do I have to raise 5 to get 5 squared? Obviously, it's a 2. How about this one? Log base 5 of 5. What do I have to raise 5 to get 5? 5 to the what is equal to 5? Well, clearly that's a 1. All right, ready? Here's a couple more. They get a little bit tricky now. Log base 5 of 1. So this one says, what do I have to raise 5 to get 1? What do I have to raise 5 to get a 1? Well, remember, any non-zero number raised to the 0 power is a 1. So 5 to the 0 is equal to 1. So this must be a 0. All right, one more. Log base 5. Oh, no, let's change it. Let's switch it up. Let's do log base 25. You ready? Of 5. Here, I switched it around this time. So what does this one say? This one says that my base is 25. I don't know why I wrote it like that. Let's write it like this. 25 to the what has to equal 5. So 25 to the what has to equal 5. Well, do you remember this one? If we want to think about it this way, we know that the square root, we could think of 5 as the square root of 25. Another way to think of 5 is to call him the square root of 25. Well, what would my exponent be? If you remember from your exponent rules, that has to be a 1/2 because that's the same thing as square root. So this one would be a 1/2. So that's a little brief lesson on how to evaluate your logarithms and what they kind of stand for. We can go ahead and, well, why don't we do a couple where we switch them before we end? How's that? Let's try it out. Let's say I have this one. Log base 4 of 16 is equal to 2. This is my log form. Let's write it in exponential form. You ready? So again, if I'm going to rewrite this in exponential form, which is kind of what we were just doing a second ago, we want to read it out loud. Log base 4 of 16 is equal to 2. So the base is 4. The logarithm is always equal to the value of the exponent is equal to 16. So this is converting from log form to exponential form. So we took this log and we rewrote it like an exponent. Now, if I could also go the other way, if I said 2 to the third is equal to 8, this would be my exponential form. And if I wanted to write it in log form, well, what would I do? Well, I'd start by writing the word log. And what would I write? I would say base 2. I know that it has to be equal to the value of the exponent because that's what logs are equal to, the value of that exponent. And the value that it's equal to is 8. So that's writing exponential functions or exponential equations into logarithmic form and logarithmic form into exponential. There's a few more things you probably want to know about logarithms, but maybe we can save those for the next video. That will probably get you started on just the basic ideas of what a logarithm are.